Opening. Have you ever stopped to think? We've been using kitchen range hoods for over 40 years. But what if the cold technical path of range hoods was wrong from the very beginning? This might sound surprising. Today, I want to walk you through this question using the simplest logic possible. Let's re-examine something we've never truly questioned. Why do range hoods look the way they do? Why do they work the way they do? And are they actually suited for real cooking, especially in Chinese-style kitchens? Part 1. Real innovation starts with questioning, not optimization. I believe original technology evolves through 4 stages. First, knowing what it is. Second, knowing why it works. Third, questioning why it must be this way. And finally, creating an alternative path. Most companies stop at the first 2 stages. They know what a range hood looks like. They know why it's designed that way. But the rarest step is the third one, questioning what everyone assumes is already correct. Because without questioning, true creation never happens. And the range hood is a perfect example of this problem. Part 2. For 40 years, China never left the Western framework. Range hoods entered China in the 1980s. What did we do then? We took them apart. We studied them. We copied them. And we kept strengthening the same idea. We knew what they were. We knew why they worked that way. We reproduced that logic again and again. And slowly, we became trapped inside it. Bigger suction, stronger motors, more extreme parameters. But we never asked a fundamental question. Was this technical path correct from the start? Why must a fan sit in the middle? Why is bigger suction the only direction? Is it possible that for decades, we've been pushing harder on an inefficient path? Part 3. Meat. Pez suction. A reasonable design with hidden flaws. Let's look at the real path of cooking smoke. Smoke forms at the pan, gives rises freely and spreads. Gets put into the hood, moves through the duct, gives and exits the building. Traditional range hoods are installed right in the middle of this path. They attempt to do 2 jobs at once. Capture the smoke and transport it away. This middle position design seems reasonable, but it has several fundamental problems. Part 4. Fatal flaw number 1. We misunderstood suction for 40 years. We've been taught one idea so deeply that almost no one questions it. Range hoods work by suction. People believe it must be suction. It can only be suction. Without suction, nothing works. But what is suction, really? Range hood suction is, in fact, static pressure differential. And static pressure has 2 key properties. First, it is extremely efficient, but only in closed environments. A vacuum cleaner works because its airflow is confined. Second, in open spaces, static pressure collapses rapidly. While a vacuum must stay close to the floor, just a few centimeters of distance dramatically reduces effectiveness. Now apply this to a kitchen. The hood inlet is 20 to 40 centimeters away from the pan. That space is completely open. Static pressure struggles to reach the moment smoke is created. And here's a critical part. Cooking smoke begins spreading outward. Within 0.2 seconds, the smoke spreads faster than static pressure can reach it. That's why, even with massive airflow numbers, smoke still escapes, hits your face, and spreads into the living space. It's not that suction isn't strong enough. It's that suction itself is the wrong tool at the wrong moment. Part 5. Fatal flaw number 2. Pushing airflow is energy inefficient. There's another hidden problem. Traditional hoods push smoke forwards to ducts, but in fluid dynamics, pushing flow is inefficient. Every bend increases loss. Every meter increases resistance. More power means more energy waste. That's why identical airflow ratings can feel completely different in real kitchens. This is not a parameter issue. It's a structural inefficiency. Part 6. Fatal flaw number 3. Smoke dispersion is irreversible. Smoke disperses in 0.2 seconds. Once dispersed, it can only be diluted, not precisely captured. What many hoods actually do is replace the air in the kitchen, not capture smoke accurately. That's why enclosed kitchens work better, and open kitchens almost always fail, because no hood can control the airflow of an entire open space. Part 7. The real problem is the technical path itself. When we return to first principles and ask, what should provide capture force? Where should that force be placed? How should transport be designed? The answer becomes clear. The problem is not insufficient suction. The problem is wrong capture logic, wrong force placement, wrong airflow path. For 40 years, range hoods have been optimizing along an inefficient technical path. Ending. This is the end of part 1 and the beginning of part 2. This is why questioning matters. When you question, the real problem finally becomes visible. And once the problem is clear, the solution is often simpler than expected. Range hoods should not look like this. In the next episode, we'll explore a completely different approach. A wind tunnel-based smoke control system that changes everything. See you in part 2.